Suppose you needed to lift something, and there weren't any simple machines to help you. You'd have only your own muscles to rely on to do the work. The stronger you were, the easier it would be. If you weren't so strong, you might try to think of something to help you. A rope passed over a branch might help make the work easier. But it would also have its problems, with friction, for instance. To solve this problem, you might think of using a wheel, one with a groove in it, mounted so it can turn, and so you can hang it from something. When a rope is passed over this, it can move with much less friction than it can scraping over a branch. The groove in the wheel keeps the rope from slipping off. The whole arrangement, the wheel and the rope that goes over it, is called a pulley. Pulleys are simple machines that help people do work. This one is a fixed pulley because it stays in one place as you use it. How does a fixed pulley make lifting things easier? Suppose you attach a weight or a load here. A pull down on your end of the rope causes a pull up on the other end. You apply a force in one place, and that produces a force in another place to lift a load. The amount of force you apply is the same as the force that acts on the load. If the load weighs 25 pounds, then you have to pull down with a force of 25 pounds in order to lift it. And if it weighs 50 pounds, you have to pull down with 50 pounds of force, the same amount of force you'd need to lift the load without the pulley. So a fixed pulley does not increase your force. It helps you lift things by changing the direction of force. It allows you to pull down in order to lift something up. For instance, if you want to raise a flag up a pole, you don't have to climb the pole and pull it up. You can put a fixed pulley at the top and raise the flag without leaving the ground. Fixed pulleys aren't enough. You also need a different kind of pulley, a movable pulley. It's called that because it moves with the load. The pulley is suspended by this rope, with one portion of the rope, or rope segment, on each side. Each rope segment supports half the load. If one person supports the whole load, he supplies all the lifting force himself. But suppose two people each hold one of the rope segments. Then they share the lifting equally. They each need to lift with only half as much force. Exactly the same thing happens if one end of the rope is attached to something that doesn't move. If you're lifting the other end, you still need to lift with a force equal to only half the weight of the load. This end still supports the other half. And because the rope can roll through the pulley, when you pull up with your half, you raise the whole load. So when you apply a force here, the pulley lifts with twice as much force here. With 10 pounds of force, you can lift a load that weighs 20 pounds. Of course, now the load includes the weight of the movable pulley. With 25 pounds of force, you can lift a load that weighs 50 pounds. And with 50 pounds, you can lift a 100-pound load. But with machines, you never get something for nothing. To get this increased force, you have to move your force an increased distance. If you want to lift the load a distance of 1 foot, you have to move your force 2 feet. To move the load 2 feet, you move 4 feet, always twice as far. So when the movable pulley is suspended by 2 rope segments, you have to exert your force over twice the distance the load moves, and in exchange the pulley lifts with twice as much force as you do. But one big problem with movable pulleys is that you have to pull up, and for heavy loads that's not always easy. You need something that will allow you to lift by pulling down instead. But that's what a fixed pulley does. Suppose you combine the fixed pulley with the movable pulley to get the advantages of both. The movable pulley still doubles your force, and at the same time, the fixed pulley lets you pull down. So here, finally, is a simple machine that really does make lifting easier. With this arrangement of pulleys, you can lift twice your own weight. One way to compare different pulley arrangements is to use the idea of mechanical advantage. Since this pulley arrangement doubles your force, it has a mechanical advantage of 2. You can find the mechanical advantage of any pulley arrangement by simply counting the rope segments that support the movable pulley, in this case, 2. It doesn't matter where this end is attached, so for convenience you could attach it here, like this. The mechanical advantage is still the same because the number of rope segments that support the movable pulley is the same, 2. Why isn't the mechanical advantage 3? Aren't there 3 rope segments? You don't count this one. You only count the rope segments that directly support the movable pulley. A mechanical advantage of 2 is some help. But if you need to raise very heavy loads, you need more lifting force. You get it not by adding more muscles, but by using combinations of pulleys that give you more rope segments. Suppose you add another fixed pulley, for instance, and run the rope this way. Now 3 rope segments support the movable pulley, so the mechanical advantage is 3. Or suppose you start again with this combination, and then add another combination just like it. So you have 2 movable pulleys and 2 fixed pulleys. And then hang the load from both movable pulleys. Now, how many rope segments support the movable pulleys? 4. So that's the mechanical advantage. But why does this combination make a mechanical advantage of 4? How does this work? Let's imagine that you and 3 other people were each holding a segment of the rope. It would be clear that each person would support 1/4 of the load. If the load weighs 80 pounds, each person supports 20 pounds. But it doesn't matter what holds up the segments. So if you attach this segment here and join these 2 segments over a fixed pulley, each segment still supports 20 pounds, and you still pull with 20 pounds. But because the rope can roll through these pulleys, when you pull up with 20 pounds, that raises the whole 80-pound load. The pulley system multiplies your force by 4, so 4 is the mechanical advantage. To make things even easier, you can add another fixed pulley. So you can still apply your force to this rope, but now you can do it by pulling down with 20 pounds. The movable pulleys are still supported by the same number of rope segments. so the mechanical advantage is still the same. The pulley system still multiplies your force by 4. And in exchange, you have to exert your force 4 times the distance that the load moves. You trade distance to get force. Now, suppose you arrange these pulleys in a much more compact way. You can put these 2 pulleys next to each other on the same axle. The same with these 2. The pulleys still work the same way, and the mechanical advantage is still 4. This device is called a block. This is another block. The whole system, pulleys, blocks, and ropes, is called a block and tackle. The more pulleys and rope segments in a block and tackle, the greater the mechanical advantage, and the heavier the loads you can lift. So pulleys are